Okay, next stage is to generate flow solution for this blackhawk. So I'm back in the project view area. So I'm going to create application for the steady state solver. So that's simple foam. So when the solver starts, the first thing to do is to import the mesh. So you can only import a mesh into the flow solver. You can't import a geometry. So import the mesh, and this is the only mesh that we've got in this project. So I'm going to click on that. So after a few seconds, it loads up the boundaries, the boundary conditions. And the VTU is the actual volume mesh. So after a few seconds, that has been uploaded. And so first thing to do is to select a material. And select material, it's on air. So that's okay. Next thing is to go to turbulence. I could select the Kepler or the Omega or SST. I'll select Omega for a change. Boundary conditions. So we just need to go through the boundary settings and check that we've got the right ones. So the one marked back is actually the top wall, so we want that as symmetry. Front, I'm looking for the bits that are highlighted. So the front, that wants to go symmetry. The inlet, that is actually an inlet, so we'll come back to that in a minute. The lower wall, that wants to be a symmetry. The outlet, that's also a patch, so that's okay. Patch 0, that's a wall, so that's all good. And the upper wall, and that wants to be a symmetry too. So basically, looking here, we've got 4 symmetry boundaries. We've got 2 patches for the inlet and outlet. We've got 1 wall, so that is all okay. So if I go first to the inlet, boundary type patch, I'm just going to select this as a velocity. So for the pressure, it wants to be 0 gradient. You have to be careful with these because it's quite easy to set them to the wrong value. For a velocity, we want a fixed value, so that could be, say, 100. I mean, that's probably a bit too high, but that's okay. So we've got a 0 gradient, we've got a fixed value, and then for the turbulence parameters, I calculated these beforehand. So we've got 1.5 and 1.74. And for the viscosity, got 0.85. So it's quite useful to use some sort of tool, which will be available soon, but some sort of tool for estimating the turbulence values based on the velocity and the intensity and the length scale and so on. So if you do that beforehand, then you can be prepared for that. So I think that's the inlet boundaries. 1.5, 1.74. Yeah, that's right. 0 gradient. Okay, so for the outlet, Outlet wants a fixed pressure. So we can put 10 to the 5. Velocity wants to be 0 gradient. And these others can be so with an outlet boundary, everything is 0 gradient, basically, except the pressure. That's for a subsonic outflow boundary. Okay, so initialization, kinematic pressure. Actually, come to think of it, 80 can be more accurate because boundary conditions, the outflow. Yeah, because it's in simple foam, it's kinematic pressure, which is basically pressure over density. So you have to be a bit careful of that and reduce the pressure accordingly. So here, we don't have to specify all of these values, but 1.74. Yeah, you don't have to specify all of these values, but it kind of helps convergence if you set something realistic. So we've got all of those set. Solver settings, residual control. And you don't have to do this, but I normally like to reduce these a little bit just to give the solution a bit more stability. But it's a case of trial and error really, and see what works best for your particular case. I'm going to leave the default settings, monitors. I'm not going to add in monitors. So I'm just going to run that and come back to it in a bit. I think 1,000 iterations will be good enough to get a rough idea of what the flow is doing. So let's set this running and see what happens. Actually, I can change machines and get the solution a bit quicker if I go to 1, 2, 4, 8. Let's do it on a 4 processor. Close that, run, and come back to it in a few minutes. Okay, when the solver's finished, again that took about I don't know, about 10 minutes if that, but the flow solver output from simple foam goes to the screen, and you can have a look at the monitors or the convergence while it's running, and 1,000 iterations seems plenty for that case. It's fairly coarse mesh, and so then we can have a look at the flow solution. So it takes a few seconds to load in the solution files. So the VTU one is loading at the moment, which is the volume mesh. Okay, so that's downloading some of the boundary conditions, and there's the flow solution. So straight away it shows us a pressure legend in the bottom. So I think first of all I would like to switch off the volume mesh and switch on patch 0. So let's get that a bit closer. I can adjust that. Okay, and so that, in theory, we can have a look at the velocity on the surface, or although I guess that's the near wall velocity because it's the wall boundary conditions. So we really want to have a look at the pressure contours. So let's just change that to parallel. So yeah, we can have a look at the pressures on the surface. Oh. The manipulation is a little bit twitchy. Sometimes you zoom in and then it zooms out again. But I mean, bearing in mind that's a very coarse mesh, and we've got a flow solution on that in a matter of minutes. So that is pretty good, really. And that's literally the first run of this test case on this geometry. So we can have a look at the pressures there, which is great. And if you go up to results scene, then it takes the highlight off, so you can see it as without any other lines interfering with it. So the next thing I want to do is to, I think I'll switch back on the internal mesh, and if I display the patch, then what I want really is just the surface geometry showing on that one. So I should get rid of the pressures, and then I can go back to internal mesh. Create a slice filter. Z normal. I think I'm going to switch off this patch now because it seemed to be slowing the graphics down a bit. Right, so I'm on the slice filter, so I just need to apply that. And that is not Z normal, so I'll just select that again. Apply that. And just adjust the view again. And then from there, I can select the velocity because we're looking at that. So we can see the velocity on the cut plane through the center, and so I can move that about, zoom in on that. Oop. And if I click on the surface filter again, I can select surface with edges if I want, and see what it looks like with the edges on. And I've got my velocity contour there. So just change that to parallel projection. Oh, it's already on parallel. And if I want to adjust that, the velocity contours, then I can rescale data to range, or select custom range. So we know it is 100 meters a second, so I could change that to 50. Oop, to 120, say. And we can see straight away that the legend is also changed to those values, so you can zoom in on a particular region of interest. So yeah, that's it really. So that's a fairly quick demonstration of getting a flow solution on an aircraft and having a quick look at the pressure contours and the velocity on the cut plane.